Good morning.
Good morning, Professor.
Yeah, good morning. I think all of us are there. 1, 2, 3.
Good morning, sir.
Good morning. So, welcome to the workshop. So, we'll start in a minute. Just waiting for everybody. 1, 2, 3, 4, 5. Yeah, everybody is there. So, we'll start. Yeah. So, there were a number of workshops before this, which were talking of several techniques. And the previous workshop that 1 or 2 people of you have attended has done it. We talked about a CFA. So we'll revise that CFA part and go to the other part of ACM. So basic of ACM we'll start with. We'll revise CFA and the structural model, the 2 parts of ACM in today's workshop. So let me share the screen. A little bit of theory will be there initially, but then we'll go to hands-on after that. Yeah. So this is, yeah. So we'll be talking of structural equation modeling. Okay. So before we start, anybody have any idea what is ACM or structural equation modeling?
Good morning, sir.
Yeah, good morning.
This is scholar IMI Bhubaneswar.
Yeah.
As per my knowledge, it's a multivariate techniques.
Yes.
Make multiple relationship. We understand the multiple relationship among different variables.
What are the other techniques where you can have your relationships?
Can do multiple regression analysis.
And that is regression analysis is one where you talk of relationship between the dependent and independent variables. Now, before regression analysis, there is another technique called as EFA or factor analysis, where you try to group variables. So, ACM is also a multivariate technique. Only difference is that it is not talking of only dependent-independent relationship. It is not talking of factor, but it is talking of together both of them. That is, factor analysis and regression is combined in ACM. And we have multiple independent-dependent relationship being done together. So basically, it examines the structure of interrelationships, which are a number of equations. In regression, there is one equation, but here in this case, ACM, we have a multiple equations that we can think of. So let me go to that an example. So this is somewhat what we are talking of. Had you done regression, you had to run for this particular model, you had to run number of regressions together. So one regression would be with customer loyalty as Y and satisfaction and complaints as X. Another regression will be as complaints as Y and satisfaction as X. And then satisfaction as Y and then value, quality and expectations as X's. So in this way, you have to do number of regressions if you have to test every relationship in this model. But in case of ACM, you do it all together. That's exactly we are talking of in ACM. But that is the regression part, that there is an analysis factor part also. So in case of EFA, you do a factor analysis where you explore and find out the factors or dimensions within our data. You have large number of constructors, you reduce them into large number of variables using factor analysis. But the thing is that in that case, you need to explore. In case of factor analysis or conformative factor analysis under ACM, you do not explore, but you already have the factors in place. You recheck the thing, the factor structure. And that is done through measuring the error variances or to account for basically the unexplained variances due to the variables which are not considered. Now, in this case, there are 2 variables, latent and observed variables. And with those variables, we estimate the complex relationship or series of dependent independent relationships. Now, what is this latent and observed variables? Observed variables are the measured variables or manifest variables or the indicators basically. So basically that is the items that you are using in your questionnaire. They are your observed variables. And those observed variables form the factor, which is the construct, which is the unobserved or latent variable that we are talking of. Now, one is these latent and observed variables, fine. Now, there are certain terms that you need to know before you go into details of anything else. One of them is latent and observed variables. The other is exogenous and endogenous variables. Now, what is this exogenous and endogenous? If you talk of regression, there is a dependent variable, which is y. There is a independent variables, which are x's. So your exogenous variables are those which are your independent variables. An endogenous variable is that which is the dependent variable or y. It looks like this. In this is an example, a simple example of technology adoption model: perceived use, perceived ease of use, perceived utility, perceived ease of use, and intention to use. So in this case, which can be an exogenous, which can be an endogenous variable? Can anybody tell me? Exogenous is independent, endogenous is dependent. Which can be your y or dependent variable, which can be your x or independent variable?
Good morning. This is Nagendra.
Yes.
Can you hear me, sir?
Yes, yes, very much.
Yeah. So use 1, use 2, use 3 are the dependent variables, and therefore they are.
No, don't go into that. We are talking of only the PU, PEOU, and intention to use. The latent variables.
Okay.
We are not talking of observed variables, which are the use 1, use 2, use 3, or PU1, PU2, PU3, or PU1, OU1, 1, 2, and 3. These are basically the items in your questionnaire, which are used to measure we are talking of the factors or construct level. PU, PEOU, and intention.
Okay. Then in which case PU is the exogenous variable.
Yes.
And PU is the endogenous variable.
Okay.
Dependent variable.
Yes. So dependent variable is the endogenous variable, which is in case of we take of the relationship between PU and PEOU. PU is the dependent variable or endogenous variable, and PEOU is the exogenous or independent variable.
SEM ಬಗ್ಗೆ ಅಟೆಂಡ್ ಮಾಡೋಣ ಇದೇ ಇರುತ್ತೆ ಆಫೀಸಲ್ಲಿ ಕೆಲಸ ರನ್ನಿಂಗ್ ಅರೌಂಡ್ ಸ್ವಲ್ಪ ಡಿಫರೆಂಟ್ ಮಾಡೋಣ ಅನಿಸ್ತು.
That is when you are talking of, yes, Anikar. That is Anikar.
Yes, sir. Yes.
Yeah. Very unusual name.
It's my surname. My name is Manavi, Professor.
Okay. And that's why I was surprised. Okay. So correct. In this case, independent variable is your PEOU, and intention to use also is dependent variable. But there are two equations here. One is PEOU to PU. So in that case, PU become an independent or exogenous variable, and PU becomes endogenous or dependent variable. But if you take intention to use as endogenous or dependent variable, then both PU and PEOU becomes your exogenous or independent variables. That's why I said multiple equations together can be done. Now coming back to the next set of concepts, then there is something called as reflective constructs and formative constructs. Now what is this reflective versus formative constructs? So if you talk of reflective versus formative construct, in case of Amos, when you use Amos for SEM, you have reflective and formative construct, but Amos talks of only reflective measurement. So if you see the previous diagram that we talked about, you can see the PU is reflected on PU1, PU2, PU3. So the factor is reflected upon. It is not forming the factor PU, but PU is reflected through PU1, PU2, PU3. And similarly, intention to use is reflected to use 1, use 2, use 3. The arrow is from intention to use the construct to the item level. That is what is known as reflective construct. So basically latest constructs or the cause the measured variables. That is what is reflective in. But there are certain cases, in case of management and all those, we generally talk of reflective construct, and AMOS, when you use AMOS or ACM, we generally take care of only reflective construct. Formative construct cannot be used in that case. So formative construct is had the arrow been in the opposite direction, that is PU1, PU2 and PU3 forming PU. So that is the difference between reflective and formative constructs. So indicators are causes of the latent construct, and in case of formative, in case of reflective, the indicators are effects or manifestation of the latent construct. So the difference is there. Now, when you talk of simple management level things, when you are using AMOS, the customer commitment towards a brand can be your latent construct, and then that is built through the other observed constructs like willingness to buy or word of mouth or continue buying and all those. That is reflective. But when you are talking of building an index, let's say you are trying to build a social class index, and then you use education, occupation, income as your items. And in that case, you can use a formative measurement, or that is an example of a formative measurement. But in case of ACM, using AMOS, you cannot have formative. It is basically reflective when you are talking of. Then there is something called as recursive model. Now, what is recursive model? Recursive is basically you are talking of loops, both way loops, feedback loops. When you are talking of feedback loops, then we are talking of non-recursive. And when there is no feedback loop, one-way arrows, then we are talking of recursive. So in case you're using ACM through AMOS, we use recursive models because we do not take care of, or feedback loops cannot be done in case of ACM through AMOS. For example, can be something like intelligence is leading to success in studies, or success in studies also leads to more of intelligence. So both way it is true. So in that case, it is a non-recursive model or a feedback loop, both way arrows, which is not possible in case of ACM with AMOS. We use only one-way arrows, the recursive models. And then there are two parts. Till now, everything is clear, or any doubt on any of this? Anybody?
Professor, one doubt. When we take second order construct, so we are going with again reflective constructs, right?
Yes, everything is reflective in ACM with AMOS.
Okay, yeah.
In management science, in social science, generally very rarely we have formative constructs. Formative constructs are only used when you are talking of something like social class index, etc. and all those. When you are building an index, it is a formative construct. But that is generally rarely used in social science. Okay?
Yes, Professor, got it.
Yeah. Now, as we have said before, when we are talking of ACM, it is having two parts. One is the measurement model, which is the CFA or confirmatory factor analysis part, which is the factor part. And then there is the structural model, which is the regression part. So there are two models, measurement model and the structural model. Basically, measurement model, as I said before, is something like your factor analysis. Only in this case, you do not explore like in EFA. You generally know these are the factors under which these are the items. You just confirm that factor structure. And that is why it is not exploratory factor, but confirmatory factor analysis. And the structural model is the regression relationships or effects are shown. Now, both of them have certain notations. So when you are talking of measurement models, these are the notations generally we use, where we are talking of factor analysis part or CFA part. And when you are talking of structural model, the notations are slightly different. And the diagram also is slightly different, if you can see. This will become more clear when we go into practical hands-on, which will go very soon. We will not waste much of time on these things. We will go to the directly towards the practical part, hands-on. Now, what do you do in an ACM? Because it is talking about modeling. Na? So what is the purpose of the statistical modeling? In case of ACM, whether we are trying to find out whether there is a fit between the hypothesized model and the data, whether the model fits the data or not. And how do you estimate that? You estimate that through this. The observed covariance matrix and estimated covariance matrix. You try to find out how close they are. The closer they are, the better is the fit. And if exactly equal, then the fit is perfect, which is never possible. You cannot have a 100% exactly fit model, just like you cannot have a 100% normally distributed data. We often say we are tracking for normal distribution and we want to have normal distribution and we have 100%. If somebody says 100% normally distributed data, then you can safely put that person to jail. That is not possible in any way, in any case. Now, how to measure that fit and all those, we'll come to that as we do the hands-on. So there are ways of measuring that fit. There are fit indices, which is there in ACM. So first we'll go into CFA. As I said before, the measurement model or CFA. There are two names. It is called as measurement model or confirmatory factor analysis or CFA. So basically in this case, unlike EFA, again and again I'm saying, unlike EFA, it is talking of confirming a factor structure. The factor structure is already there. In EFA or factor analysis, exploratory factor analysis, we're trying to find out among the variables what are the factors. Here we already know the factors and which are the variables under the factors. We try to find out or confirm that factor structure. So the difference diagrammatically can be measured like this. When you are talking of EFA, it looks like this: factor 1 and 2. Every variable leads into every factor. In case of CFA, we know that these are the variables which are under these factors, and we confirm that structure and nothing else. That's exactly we do. So EFA explores the data for patterns, where CFA, you need to clearly specify the factor structure before the results could be computed. So it tells us how well the specification of the factor structure matches the reality. So it is basically a confirmatory test of the factor. So we'll go to the hands-on now, but before that, we'll have one more thing. Sorry. This is important in any case of ACM models. I have showed you those factor structures. So these are latent constructs. X is latent construct, and the observed variables or items are X1 and X2, or X1, X2, X3 in the second one. Now it's very important to have a identified or over-identified model. Now what is identification? Here comes the concept of degrees of freedom. Can anybody tell me what do you understand by this term, degrees of freedom? Anybody? What is degrees of freedom? You often use that term.
It's possibility of estimates, how many estimates we can do.
So degrees of freedom is calculated through two values. I'll give you an example. Let's say there is an equation called x plus y equal to 4. So what is the degree of freedom of this equation?
1.
-1. The formula of degrees of freedom is known values minus the values to be estimated. So when you're talking of x plus y equal to 4, there is only one known value 4, and there are two values to be estimated, x plus y, x and y. So 1 minus 2 is minus 1. So number of variables or parameters to be estimated, that is to be subtracted by the known values that you have in hand. So degrees of freedom is always like that. So if you have to solve this equation, you need another equation. Let's say x minus y equal to 2. In that case, you will have a 0 degrees of freedom because you have two known values, 4 and 2, and two values to be estimated, that is x and y. So in the same way, in this case also, the number of constructs that you have and the number of items under that construct helps you to calculate the degrees of freedom, and that degrees of freedom has to be positive. So if it is negative, then it is under-identified. If it is positive, 0, that is just identified. But you need the degrees of freedom to be positive. And then over-identified model is what you need in case of running the model. So let's take the first one. You have 4 parameters to be estimated, LX1, LX2, U1 and E2. And you have 3 known values, the variance of X1, variance of X2, and the covariance between X1 and X2. And in this case, it is the degrees of freedom is 3 known values, 3 minus 4 to be estimated, minus 1. And that means basically you have an under-identified model. In the second case, you have 6 parameters to be estimated and you have exactly 6 known values, 3 variances, 3 known covariances. So it is just identified model, 6 minus 6, which is 0. In case of variable, I am taking an example with only one construct, but in case of ACM, you have number of construct, each of them will have number of variables under them. So you need an over-identified model where degrees of freedom needs to be positive. Otherwise, the model will not run properly. That is the problem with the ACM if you are talking of an under-identified model. And in that case, you need to, what you need to ensure is, you need to ensure that on average, total number of items divided by total number of constructs should be always more than the, on average, should be more than 3 or more. Then you will be safely having an over-identified model. If you are not having that, then it becomes a problem and you may have a problem of under-identified model. So we'll talk of that, and as we do the hands-on, it will be more clear to you. So this was basically a small theory part which we have used. So we'll come to the hands-on now, and as we do the hands-on, the things will be more clear to you. Yeah, 1 second. So we'll straight go to the hands-on part. Yeah. So this is the basic screen of AMOS where you do the diagram first, the constructs and etc. you draw here, and you try to estimate the model CFA. So I will show you the model before, but just let us look at how to draw this diagram. So let's say you have 4 constructs and you have around 3 or 4 variables under each of them. So you need to draw them. How to draw it? You need to go to this particular value, draw a latent variable or an indicator to latent variable. Click on this, come here. So you have this latent construct and then the variables under it. Similarly, second one. Third one. And fourth one. Now it becomes sometimes very messy to because all are in one direction. So just to arrange them, you can rotate these indicators. This rotating indicators button has to be taken. and you rotate it so that it looks much better and more arranged. So you have drawn diagram like this. This is latent constructs and your variables or items under it, and the error terms will be these small circles. And in case of CFA, because it is a covariance technique, you need to have a covariances drawn between the latent constructs.
Sorry, sir.
Yeah.
Just 1 second again. Draw this one. I am unable to get that. This particular drawing.
You have to use this button. Take this button and just click on here on the screen, and the number of indicators that you need to group it, just go on clicking on that. Clear?
Yes, sir. Yes, sir.
Now, this is basically how you draw it. And then when you need to select, draw the covariances between the latent construct. So for that, you have to select one object at a time, select this diagram, and select all the 4 latent constructs. And then go to the plugin and draw covariances. All the covariances are drawn. This can be done manually also by using this both-headed arrow, but that becomes a problem because what happens is that then you have to do one by one each way. And if you have a large number of constructs, this can be done in this way also. But if you have a large number of constructs, then it becomes a problem for you to draw. You may miss out on one of them. If you miss out on one of them, it will become difficult to estimate. The model will not run properly. So we don't want to waste time on everything. So I've already drawn the diagram with the data set. I have sent you a data set yesterday. So I'll go directly to the data sets. Yeah, this is the data set I have sent you. Now, what are there in these data sets? What are the variables there in the data set? I will come to that. The variables are this. Yes. So you have 6 latent constructs: customer satisfaction, customer loyalty, technology usage easiness, technology security, staff competence, customer service. This is a data which is a part of my research thesis. Basically, this is one of the data sets from my thesis, which I have done long back. So this is only a part of it. It is not complete data set. So I have tried to find out the service quality constructs or dimensions in case of banking, where both technology and human interactions are used. And there are certain things, dependent variables, customer satisfaction, loyalty, and all those. So the numbers that you see under each of them, 4, 3, 4, 6, 6, you can see they are the number of items which are used to measure those constructs. So number of boxes under each of these constructs will be like this. So it will be more clear as I show you the diagram. Yeah. Yeah. So diagram is this. The same data that I am showing you has been put in diagram. So I've not wasted time for drawing each of them one by one. It will take a lot of time. I've already drawn the diagram. So this is the diagram. The 6 latent constructs are there. Under each of them, there is a variable or item which is used to measure it. So as per that, 2 of them has 4 variables under it. one has 3, and the rest has 6 under each of them. So average of 6 is how much? 29 by 6, which is almost 5. That's exactly what we said when I said that at least 3 variables on average should be there under each construct. Otherwise, you can have a problem of under identification. So in this case, that problem is not there because you can see there are 29 items and you have 6 constructs. So 29 by 6 is almost equal to 5. Clear on this before we move into another things. The same data set that I have sent you that has those stated constructs or variables. The Dart file that I have sent you has given the constructs definitions, the number of items and what are the constructs. And that's exactly I have drawn in this diagram. Any doubt here before we proceed any further? Okay. So in the similar manner, I have drawn those circles and their indicators as well as these covariances. I have used plugins to draw those covariances and everything. Now, the diagram that I have showed you previously used to have blank ones. Then you need to name them. So how to name them? For that, you need to first load the data file. And how to load the data file? You need to go to this option called as select data files. This is the option. So there you need to go to the particular file wherever you have kept your file. Go to that and select that data. One more thing, the data that we select, the data file should be either .csv or it should be an SPSS file. It cannot read directly an Excel file. So the data has to be saved in CSV format or in the SPSS format. Both the data sets can be read directly by Amos. So once you select the data file, you can see this value comes 290 data points. There are 290 respondents or data points in that valley. If this value comes, that means then you are sure the data file has been selected. If this field is blank, no value is being shown, that means the data file is not yet selected. So you have to again go back and select the data file. Once this value comes, that means the data file has been loaded into the Amos. And don't keep the data file open and try to load the data file. You have to close the data file and then load it. Otherwise, it will not load properly. So once you have this data file, you can go to this option called list variables in the data set. And from there, you can directly drag and drop these names here. Looking at these data variables, you can give the names to them. The variable names can be given directly by dragging and dropping the names, or you can type it out by having this as a reference. You can type it out on these variables. And this, how do you type it out or how do you name them? Just click on this, any of the variable boxes which is blank, go to object properties and give that variable name. Type out the variable name. Similarly, for all the error variances or errors also, you need to go to that object properties and type out the name. In fact, for naming, once you have these latent constructs in CS1, CS2, CS, ER, ER1, all these named, this naming can also be used by selecting the plugin. You can use this name parameters option. Name unobserved variables option. And then it will name all the error files, these error terms directly instead of typing out everyone. Otherwise, you have to go to each of them, go to object properties, and then type it out the variable name. So instead of doing that, you can use the plugin and it will name all of them together. Only for the errors. For this, you have to do it separately, manually, because each one has a different name. That's why. So don't make any mistake here, because if any of the mistake is problem is that if it is exactly same as the data file. Whatever name has been given in the data file, you have to use the same name here, CS, CS1 and all those. Otherwise, it will not, the model will not run when we are running the model. Clear? Or any doubt? Till now. Anybody? No doubt? Yes. So let us go to the next part. Once you have this diagram ready, then you need to go for running the model. And for running the model, you need to look at this called as analysis properties. So click on these analysis properties, go to output. In that, you need to check on these variables only: minimization history, standardized estimates, squared multiple correlations, modification indices, indirect, direct and total effects, covariances, correlations, and tests of normality and outliers. These are the buttons to be checked in the output tab. 1, 2, 3, and 8 on the left hand side. 1, 3, 4, and 6 on the right hand side. So once you select these buttons, so you have to select like this. They will not be selected by default. And once you have selected it, you can close the button. And then after this, you need to run the model, which is calculate estimates, this button. Which one you are saying?
Now, which are to be selected? That.
Okay. This one. 1, 2, 3. In the output, you will only once you open it, you will have this estimation, not this. Go to output. 1, 3, 4, 8, and 1, 2, 3, and 8, and 1, 3, 4, and 6. So note it down. I'll stop here. Clear?
Yes, Professor. Thank you.
Yeah. And then once you do this calculate estimate, it will do the iteration, and this minimum was achieved. This thing will come. This chi-square and degrees of freedom. This once this comes, that means model has run. When the model was run, till the model was successfully not run, this view text button was disabled. As this is another indication if your model has run successfully or not. If your model has run successfully, that means this will become enabled. This is the output of the AMOS model. This button, if you click on that button, that will give you the output of the AMOS model. Clear? I will come to that, but that output can also be diagrammatically shown in this particular, this is the model diagram. Once you have run the model, you have run the analysis, this second bar diagram, it is showing you the estimates. It has calculated all the estimates. It is difficult to interpret and look, but at least the model has run successfully or not, you can check from this. These are the unstandardized variables or estimates. If you go to the standardized estimates, it will show the standardized value of the estimates. Unstandardized, standardized. This particular right-hand side diagram. If you come back to this, this is the original model that we have run. This second button will be only enabled once you have run the model and analysis of the model successfully. Standardized, unstandardized, standardized. Now from the diagram you cannot interpret, so you need to interpret by looking at this text output. So once you click on this view text, the output will be opening. I'll go to the output. This is how the output looks like. You have several tabs. Now this shows the degrees of freedom calculation. So it shows it is over-identified. Now calculation, how will you do? And the model is also recursive, you can see. It is needed to be recursive. It is non-recursive, it will not run properly. This shows the degrees of freedom, that thing. This is model, this analysis summary, date, time. Notes for the model is recovery. Variable summary is this. Variable list is also there. Variable counts are also there. How many observed, unobserved variables, everything. Exogenous variables, endogenous variables, all these are being shown. This is showing the covariances, variances, number of covariances, variances, etc. All these things. So now, how to come to this calculation? How have they come to this 435 and 73 and calculate the degrees of freedom? How many items were there? Observed variables. Can anybody tell me?
$29.
29. So 29, and if you have to calculate a number of variances and covariances, it will be 29 into 13 by 2, n into n plus 1 by 2. How much is that? 435. Number of variances and covariances which are already there. That is 435. Known values. 29 into 30 by 2. That is the n into n plus 1 by 2. That is the formula for number of variances and covariances or known values you have. Now, how many to be estimated? That is 73. So 45 and 73. Now, how does this 73 comes? So for that, again, we have to go back to the diagram. Then it will be more clear why or 73 is coming. Since you have 29 variables, you have 29 coefficients to be calculated and 29 error variances to be calculated. So 29 plus 28, 29 plus 29 is 58. All these regression coefficients or the beta coefficients or factor loadings, whatever you call them, these are for all 29 and 29 error variances. 29 plus 29, 58. And how many covariances are there? 6 constructs there. So inter-construct covariances are 15. 6 into 5 by 2. So 29 plus 29 plus 15. 73 are the number of variables to be calculated or estimated. So and that's why we have got that 73. So that shows the model is fine. It is overestimated. It is not having a problem of degrees of freedom in negative or 0. It is not identified or neither. It is under-identified model. It is an over-identified model. 435 minus 73, 362. So we can go ahead. And for this to be positive, again, I am saying you need to have on average 3 plus variables or items under each of the construct. So in this case, it was 29 divided by 6 is almost 5, much more than 3. Because of that, the problem of identification is not there. Clear till this?
Professor, can you just tell us once again what elements come in this number of sample moments? And
that is the number of variances and covariances between all the items. So 29 items are there, na?
Items and variance, covariance.
Yes, the items, the X1, X2, X3, all those CS1, CS2, CS3, year 1, year 2, year 3, all those 29.
Okay.
So among them, how many variances are covariances? Covariances will be 29 into 28 by 2 and number of variances is 29. So the formula of getting the number of variances and covariances is always n into n plus 1 by 2. So if you have 29 items or observed variables, whatever we call them, it is 29 in this case. So 29 into 30 by 2 will give you this number.
Yes, and in estimates,
estimates is you have 29 variables again.
Yes.
So each of them will be having a beta coefficient if you think from regression angle, or if you think from factor angle, each of them will be a factor loading. That the diagram that I showed you now, LX1, LX2, there's those things.
Okay.
So 29 those coefficients to be calculated. And each variable has 29. Each variable has one error. So 29 error variances to be calculated or estimated. So 29 plus 29. Clear?
Yes, Professor. Thank you.
Yeah. And 15 more is the number of covariances between the latent constructs. You have 6 latent constructs. And if you calculate the covariances in between them, that is 15 among them, the number of two-way arrows that we have drawn between the latent constructs. That is 6 into 5 by 2. So 29 plus 29 plus 15, that is 73. What you need to estimate.
Yes,
clear?
Professor. Yes, got it.
Yeah. Now I will straight go to the estimates part. Now what is this estimates part? This is the estimates. We'll go to this scalars, this estimate part. This shows you the factor loadings, or you call it standardized regression weight of a CFA in case of CFA. So it shows you under CS there are 4 variables, under CL there are 3, under ER there are 4, under IS there are 6. This p-value shows you the significance level, whether they are significant or not. Now each of them is highly significant. They are much below 0.000. That's why they are showing 3 stars. So this confirms your factor structures. And what is the value of those factor loadings? This is shown in this table. The value is here, the standardized regression weights. These are the values which will report in the final report when you are reporting the results of CFA. These are the values. These are the factor loadings. Here, the factor loadings are also known as standardized regression weight because they take each of those relations as one simple regression. In that way, they consider it. That's why it is called as standardized regression weight. So the values are this, and whether they are significant or not is from this. Generally, we will never found anyone which is not significant. But if the situation comes to that, you may need to drop that item from the model and rerun the equation. But what happens generally when you come to CFA, before doing the CFA, we generally run an EFA, have a very confirmed, have a very robust factor structure, and then come to CFA to confirm that structure. So generally you will never find an item which is not significantly loading. So if you are not finding that, there is no problem. If any rare case you find any of them, you need to remove that particular item. If this significant value or the p value is more than 0.05, it is not significant, and in that case you need to remove that variable item and rerun the model again. Here everything is significant, but you can see there is one problem. In each of the constructs, one item is not showing a p-value. For each, in CS it is CS4, in CL it is CL1, in ER it is ER4, in IS it is IS1, in SC it is SC6, and in S it is S6. One is having a blank and the value is showing as 1. Now, why is this showing like this? Because in this table below, the value is there for everything, but the significance is not being shown. The answer lies in the diagram. So I'll again go back to the diagram. See, for each of them, you have one particular path. The value is fixed as 1 for each of the constructs. See, for CS there is 1, CL there is 1 value, ER there is 1. So this one value is by default taken when you run the diagram or when you make the diagram. By default they will take this value. And so what happens? You need to, this p value will not be shown for this because that is fixed as 1, and this is needed in order to run the model or run the analysis. This is something like an iteration that is going on. For that, they want to have a starting point, and that's why this is fixed as 1. Now, how to check the p value for this particular? The factor loading or regression weight is there for everything, but the p value, whether it is significant or not, you cannot check for one variable in each of them. So what you need to do is that if you want to really check it, in CS, you can see CS4 is having that value 1. So what you do, go to that arrow, go to that object properties, and remove this regression weight and transfer it to another one. Let's say CS1 and put the 1 here. Once you have done it, you need to run the model. See, before you, when you have made any change, the text output button disabled. Once only the alphabet estimates button is done, it will become enabled and show you the output. So now I have removed that CS4 to CS1. I have moved that. For each of them, you need to do that if you have to check the ones for which the p value is not given. So once you have done that, just do for calculate estimates and go to the text output again. And now you can go to the estimates and see it is showing the p value for CS4 also. Now it has moved because 1 is moved from CS4 to CS1. So this you can do for all the 6 constructs. Change the place of one to another one for which you have not checked, already checked, And the one which is not checked or which is fixed as 1, you can check the p-value for that, in order to be doubly sure that everything is significant. Clear? Or not? Yes. Now, when you are doing this, we have talked about significance and everything. So what you need to do is, you need to report these results. So how do you report these results? I'll show you. Just like a normal EFA, you need to report these CFA results. In EFA also you report the factor measurement items and constructs and estimates and p-value and etc. and all those. So, yeah, which step? Usha. Which step exactly?
Professor, on behalf of Dr. Usha, I am talking here. She wants the step about p-value.
Okay. Okay, I'll show you. So go to the diagram and just change the place of this one from this arrow to another arrow. Oh, this is not the diagram, sorry. Yes. Change the place of p-value. So just go to that particular arrow, object properties, remove one and place it on another arrow where the one was not there initially. Clear? Yes.
Sir,
So,
sir, may
yeah, tell me.
sir, what exactly the purpose for this putting one and removing one? More clarity.
That's where the output I'm showing you, na. I'll show the output, then only you realize. So go to the output again. Yeah. So if you have that estimates, you can see the p-value is not shown for that particular path where the one is there.
Okay.
So for each construct, there will be one where the p-value is not shown.
Yes.
So to check for those ones, because the p-value, you need to be sure na everything is significant.
Right, right.
So for those ones, previously CS1 was one which was having one, CS4. So it changed from CS4 to CS1. And in case of CL, it was CL which is having CL1 which is having one. So I changed from CL1 to CL3. Now I have checked for CS4 and CL1, the p-value can be checked. So for all the 6, you need to remove the one from the one where initially it was there and place it somewhere else so that you can check for all the p-values for all the constructs, whether all are significant or not. Clear?
Yes.
That is the main whole purpose of that. You need to be sure that everything is significant, na? Because if something is not significant, then you need to drop it.
Right.
And if you drop it, then you have to rerun the model. That's the reason. Now, this is the p-value and this is the regression weight or factor loading. Just like a factor analysis, the standard deviation is the factor loading. Now, how do you report that? You report it like this. So you have the construct. Then you have the measurement items. Then you have this is the factor loading or standardized estimates that we are talking of. And this is the p-value. This AV and CR, don't look at it. I will come to that. When I come to that, I will explain. But these are the 4 ways of reporting. This is the construct. These are the measurement items. These are the standardized estimates, standardized regression weights or factor loadings, which we have got from the output. And this is the p-value. That's exactly how you report it for all the construct. Clear?
Sir.
Yes. So let us come back to those regression weights and all those things. Now, there are 2 things. One is, as I said, what is the sole purpose of your model? You want to find out whether the data fits the model or not. You have a model that you are testing, how robust is the model, which has a series of dependent-independent relationships. But here we are testing only the factor structure. All the constructs are good or not. Now, how will you do that? You have to check whether the data that you have collected is fitting the data model or not. And to check that, you need to look at something called as model fit indices. Or this is the model fit part. You can see there is something called as model fit in this. This model fit part you need to look at. The first among them is this, the first value that you need. There are several model fit indices. You look at that, you have several. People have gone on giving out model fit indices one after another, and go on going that. Because what happens is that in many of the cases, you will not get correct model fit indices. Sometimes the model will not fit properly and all those happens. So when you have so many parameters, you can safely look at some of them only and report that only. That is the reason you have used so many. The first among them is this C-mean by degrees of freedom. C-mean is nothing but chi-square. Chi-square by degrees of freedom. This value is the first model fit indices that you need to look at. So you have a number of model fit indices. Only some of them you need to look at or report, or more important ones. First and foremost, and must be reported, is chi-square by degrees of freedom, which is the most traditional method for evaluating the overall model fit. And this value of chi-square by degrees of freedom or C-mean by degrees of freedom should be less than 3 or 4. Then it is acceptable. But if it is less than 2, it is very good. But till 4, even in some cases stretching up to 5, it is acceptable. Now in this case, the value is 3.082, so it is in the acceptable range. Not in a very good range, but acceptable range. Then coming below that, you can see there are a number of values like GFI, AGFI, PGFI. These are called as goodness of fit indices. GFI stands for goodness of fit. AGFI is adjusted goodness of fit. And PGFI is parsimony goodness of fit. Now all these values you can see 0.78, 6743, 654 and all those. So in this, more important is GFI and AGFI. GFI should be above 0.5, 0.9. AGFI should be above 0.85. That is important. In this case, the values are less than the acceptable value, 0.9 and 0.85. Even PGFI should be around 0.85 or more. Just below that, you can see number of values like NFI, RFI, IFI, TLI, CFI. All of these values are the several other model fit indices, or they are called as incremental model fit indices. Like NFI is normed fit index, CFI is comparative fit index, IFI is incremental fit index, TLI is Tucker-Lewis index, So these are named after several other people who have invented those model fit indices. People have gone on model fit indices one after another. So all these values should be above 0.9. The acceptable values is above 0.9. So you can see among all these four, IFI is above that acceptable value. TLI is just a borderline case. NFI, RFI is slightly below. All this you need for reporting. Then there are two more values you can see. One is RMR value, which is known as root mean square residual. Another is this value called RMSEA, which is root mean square error of approximation. These values are, till now, what we have talked about, I square, mean degrees of freedom, and all those, GFI, AGFI, TLI, NFI, all these are goodness of fit. Now, this can be considered as something like a badness of fit. Chi-square by degrees of freedom is also something like that. Here, the value lower, it is better. Just like C-mean by degrees of freedom, by chi-square by degrees of freedom, the value is lower, it is better. Similarly, RMR and RMSEA, lower the value, it is better. Acceptable is below 0.1, which it is, in this case, RMR is 0.093 and RMSEA is 0.085. So it is acceptable below 0.1, but if it is comes down to below 0.67, it is better. Ideally, or very good is below 0.05. So they are in the acceptable range, but not very good value, 0.085 and 0.093. These are all model fit indices that you need to report. In the same file that I have shown you, I have reported that also. I'll show you. The model fit has to be reported. Chi-square by degrees of freedom, CFI, TLI, IFI, NFI, so many I have reported. RMSEA, all those. This has to be reported. But the problem here is they are not that good. So these basically are the model fit indices that you need to report. So what happens is that if some of them are not good, you can report some of them and not report the other one. But chi-square by degrees of freedom and RMSEA, RMR, one of them, GFI, AGFI, CA1, some of the CFI, TLI, at least one. For the first two has to be reported. And in the third and fourth case, at least some of them has to be reported, which are above the acceptable value. But in this case, you can see that most of them are not in that acceptable value range. Especially GFI and AGFI, and are they acceptable in like chi-square by degrees of freedom, RMR and RMSEA are acceptable but not that good, while GFI, AGFI and many of them are not even in the acceptable range. They are well below 0.9, especially GFI, AGFI, you can see. So what to do in this case? You have to do something. If you don't do something, then it becomes a problem. So what to do? You need to look at something known as, I call it legally illegal or illegally legal. And that is known as modification indices. Now, what is this modification indices? If you look at the modification indices, you can see there is a covariances table at the start. In that covariances table, you will have certain values under MI. You need to look carefully which are the values which are very high in this. The values which are high has to be the values which you need to concentrate on. And how will you concentrate on them? Can you tell me which is the high value which you can see here in this?
E22.
E22 and E23. You have to look at both the values. So I will note it down. What are the values? A very high value is E22 and E23. These are the error terms. Never look at the values. If there is a high value between a construct and error term, don't look at that. E28 and scale, don't look at that. Only between the error terms you need to see. So you can see E22, E23 is very high. Then E23, 28. Anything above 10 is quite high. This is very high. But there are certain which are there. I will go to the below. There is something E8 and E9 is very high. E1, E5, 21. I'll first look at which is above 20. This is not considered because it has been construct an error. No. E12, E13, 41. E12, E13. Then go to below 20, E18, E19. E18, E23. Yeah. So above 20, nothing more is there. So before working on this, we need to note down the model fit values. So let us note down some of them. Chi-square by degrees of freedom is having a value of 3.082. So after doing those legally illegal operations, we'll check whether the values are improved or not. GFI is 0.786. AGFI is 0.743. RMR is 0.093. I'll take some of them only. NFI is 0.871. RFI is 0.855. And let us take one more, that is RMSEA, which is 0.08. This I'm noting it down because later on we need to check whether the values are improved or not. Now in the modification indices, I have noted down 6 variables which are, if we correlate them or covariate them, then the chances are that model fit will improve. So let us go back to the diagram again. So in the diagram, the first one that we looked at is E22 and E23, which is showing a very high value. So for that, for correlating them, take this two-headed arrow and just correlate it. Then E8 and E9 was the second one, these two. Then third one was E1 and E5, these two. Fourth one was E12 and E13, these two. Fifth one was E18 and E19, these two. And the sixth one was E18 and E23, these two. So once we have correlated these things, let us run the model again. And now go back to the output again. Now we go for see we go for what? Estimates, model fit. C, chi-square by degrees of freedom has improved from 3.082 to 2.353. RMR has not improved. It was 0.093, it was 0.98. It has in fact gone down. RMSEA was 0.085. Now it has improved to 0.068, much better. And this will notice RMR and RMSEA will not improve. One of them will improve. Otherwise will not improve. Both does not go together. Let us look at GFI and GFI. GFI was previously 0.786. It has improved to 0.840. AGFI was 0.743. It has gone to 0.805. NFI was 0.871. It has improved to 0.903. RFI was 0.855. It has improved to 0.889. Clearly you can show an improvement is there in case of model fit when you are using these modification indices. So this is an iterative procedure. Let us go back to the modification indices and do one more round. Now I will talk of slightly which is near 20, not above 20, but near 20. See, there is E26 and E29, which is quite high, the value. E6, E7, E13, E19, E20, E28, okay, let us take this 4 only. So again, go back to the diagram. Yes, it is acceptable depending on, Manavi, it is acceptable depending on whether what are the constructs.
Okay. So
If the
what type
constructs
of
are somewhat similar nature, it can be. Ideally, it should not be, but it is sometimes acceptable if the constructs are similar nature.
Okay, Professor, thank you.
Yeah. So going back to the model again, we'll again correlate these 4, E26, E29. E6, E7. E13, 19. And E20 and 28. So once you have done that, again run the analysis and go back to the output again. And again see the model fit. Chi-square degrees of freedom has gone to an excellent level, 2.164. GFI has gone again up, 0.853. AGFI also has gone up, 0.818. RMR has slightly improved to 0.094. NFI has gone up 0.912. RFI also has gone up 0.898, almost in the acceptable range. Let us look at the RMSEA. 0.63, gone down, that is good. So this particular process has to be repeated till you get a more or less acceptable and good model fit. Till you get a acceptable or good model fit, you need to go on repeating this step. and check when you have got a quite good model fit which you can report, you can stop there. And the final thing that you report in your paper where you are reporting, there you need to report the final one only. No need to mention that they are model, we have done modification indices and all those. Everyone knows that it is being used. So no need to mention that. You can just directly report it in this way. The model fit, the acceptable model fit of the data has to be reported, whether they are copying or not. So that is to be reported, and as well as this table. The other two I have not yet come. I will come back. I will come to this ABCR part also. But both has to be reported. Clear till now? Or any confusion? Yes. So what we will do, we will take a break of 15 minutes and come back after the break for doing the rest of the part. We'll meet after a break. Whatever it is there, and just if you have any doubts, whatever we have discussed, and if there is doubt, you can ask me later.
Sir, this is Nagendra.
Yeah.
Hello, sir. Will you be making available the recording of this session at the end of the...
Yes. It will be there.
Okay. You will be sending the link to us for us to download, etc.
Yes.
Thank you. Thank you so much.
Send. Okay. Yeah.
Professor, you are in mute.
Hello. Now it's fine?
Yes, it is audible.
I'm muted, but it's not. Yeah. So we have talked about the model fit and the basic model and how to run it and what to report and all those. So next after model fit comes the part of the reliability and all those things. So after you have looked at model fit and improved the model fit using your modification indices, etc., then you look at reliability part. Now, reliability part, one part of the reliability is the obvious reliability which you check when you are doing EFA, that is the convex alpha. But along with the convex alpha, there are two more things which is important in this case, which checks about or which talks about the reliability and construct validity of the constructs in the model. And those are the two things that I have shown you in the table. These are the two things. One is AVE, another is CR. So that is what you are talking of, or that's not need to be calculated and reported. Construct validity, which is talking of AVE and CR values, and also the convergent and discriminant validity of the constructs. The first thing is this CR value. Now, how to calculate that CR value? So CR or composite reliability has to be between, the value is always between 0 to 1 and the value should be greater than 0.7. That reflects a good reliability. So how to calculate that formula? To formulate the formula, we have to use a formula which is in the numerator, it is the square of sum of the factor loadings or regression weights. Square of sum of factor loadings or regression weight. That is this values. Yeah. So these values I am talking of. Sum of loadings for this construct. So it will be 0.885 plus 0.901 plus 0.842 plus 0.917 for CS. For each construct separately, you have to report CR values. So 0.885, 901, that is sum of the loading values or some of the regression weights. And then after summing them up, you need to square it. That is in the numerator. So let us calculate that first for CS. Yeah. So the values are 0.885 plus 0.901 plus 0.842 plus 0.917. So you want to sum up these loadings, you need to square it. So this is the value. That will come in the numerator. Now in the denominator, value is this value plus summation of error variances. Now what are the sum error variances? That will come from this table. These error variances, E1, E2, E3 and E4. These are the errors related to CS1, CS2, CS3, CS4. That's how you have named it. So that is 0.374. So plus 0.374 plus 0.219 plus 0.285 plus 0.186. So this is the value which is in the numerator. So the denominator, sorry. So square of sum of the loadings for that construct divided by square of the sum of the loadings plus error variances for that construct. So the value is 12.56702 divided by 13.445211. The CR value for the construct of CS is your 0.934. So in this way, for all the 6 constructs, you need to calculate the CR values or the composite reliability values. The value should be greater than 0.6 to be acceptable. 0.7 and above is very good. That is one part. The second part is the AVE value.
Professor, can you repeat the denominator calculation?
Numerator is square of sum of the loadings. Denominator is sum of the square of the sum of the loadings plus summation of the error variances. What is there in the numerator is there in the denominator also, plus addition to it is the error variances which you get from this table, variances table.
Okay, Professor, got it. Thank you.
Yeah, so that is the CR. Now besides CR, there is another thing called as AVE, which was there in the table I showed to you. That is the AVE value. Now what is AVE value? It is the proportion of explained variance in the factors. So that also value ranges between 0 to 1. And you should have a value of 0.5 and above is good. The value of ABE 0.5 and above is good. It should be higher than value. For CR, it is 0.7 and above is good. For AVE, 0.5 and above is good. Now, what is the formula of AVE? The formula of AVE, I will go to that output table again so that I can explain to you. Yeah. The formula of AVE is instead of square of the sum of loading, it is the sum of the squared loadings. It is opposite. The numerator and denominator is same as in CR. Only the formula is slightly different. In the numerator, in case of CR, it was square of the sum of loadings divided by square of sum of loadings plus error variance. In case of AV, the formula is sum of squared loadings divided by sum of squared loadings plus error variance. So error variance part is same, these four values. Only in the case of square of some loadings, you need to get the square first and then add. So you need to take the numerator will be 0.885 square plus 0.901 square plus 0.842 square plus 0.917 square divided by these four values plus the error variances. Exactly. The formula is, in case of CR, it is the square of sum of loadings. In case of AV, it is sum of squared loadings. Now, in case of AV, it is slightly simpler because you don't need to actually square. The values are already available in this table. So this is the value. SMC table or squared multiple correlation table is the value where you will get the squared values of the loadings. So these are the values for CS. So what will be the value for the AV for CS? It is 0.840 plus 0.709 plus 0.812 plus 0.783. So numerator will be somewhere 3.144 and denominator will be 3.144 plus the four error variances. That is 0.374 plus 0.219 plus 0.285 plus 0.186. That is 4.208. So 3.144 plus 4.208, not plus, sorry, 3.144 divided by 4.208, which comes to 0.75. So the CAV value is 0.75. So this you need to calculate it for all the 6 constructs one by one. All the 6 constants needs to be calculated in the same way. The V and CR values and has to be reported in that bill that I showed to you. Similar way in the table that I showed to you, it has to be reported. I showed you that table AV and CR values. AV should be above 0.5, CR should be above 0.7 to be acceptable. So this is the way you report it, AV and CR values. Now, what is the use of these AV and CR values? You need to use it for something called as construct validity, which has to be also reported in the report. I have reported the construct validity here. You can see construct validity. First, we have reported the model fit. Then we have reported the reliability, which is AV and CR values. Then we have reported the construct validity. Now, construct validity was done in 2 parts. One is called as convergent validity. Another is known as discriminant validity. Now, how do you report that? The convergent and discriminant validity has to be calculated using AV and CR. So this is convergent validity. How do you establish convergent validity? All the factor loading should be greater than 0.5 and the AV value should be greater than 0.5. That's how you establish the convergent validity, which has to be checked and reported. Clear? All the factor loading values or the standardized regression weight values should be above 0.5, as well as the AV values for all the constructs should be above 0.5. If it is achieved, you have convergent validity for your model for all the constructs. The other one is discriminant validity, which is basically calculated by comparing the AV with inter-construct correlations of the constructs. So, or you can calculate. So where is this inter-construct correlation? It is there in this table. It's there in the output table. You can see there is something called as correlation. So your AV values should be more than square of these correlations. So AV value of CS should be more than square of all the correlations between CS and all the other constructs, square correlations of this construct. So square AV value should be more than square of 0.929, 0.449, 0.522, 0.603, and 0.552 for CS. Similarly, the AV value for CL should be more than the square of correlation of all these things. So you can do that also. Or the other way is that instead of squaring the correlation, you can use the correlation values directly and you can have a square root of the V value and compare it with this correlation directly. Both can be done. Either you compare the AV value with the squared interconstruct correlations, or you compare the square root of AV value with the correlations directly. So all for CS, the AV value should be more than the squared values of all the correlations between CS and other 5 constructs. This is discriminant validity. Clear or not? Both this has to be reported. Any doubt here? What is discriminant validity and what is, how do you check for discriminant validity and how do you check for convergent validity?
Professor, for convergent validity, it was like factors loading should be greater than 0.5.
Yes.
And the other condition is that I am not sure. I am not clear. The second condition.
Your factor loading should be greater than 0.5 and your AV value should be greater than 0.5.
Okay, Professor.
So these ones. All these factor loadings, this regression weight or standardized estimate, this should be greater than 0.5, these values. And your AV value should also be greater than 0.5. That is convergent validity. Discriminant validity is what? Your AV values should be more than the interconstruct correlations. Square of the interconstruct correlation. Or square root of AV is more than the correlation. Both way you can do it. But both has to be reported. Clear? Or any doubt here? Any doubt? On any of the things? So it has to be reported like this. You can report it like this. I will show you. The discriminant validity is reported like this. Yeah. You can report it in a paragraph format or you can report it in this. This is the AV value, square root of AV value, these values, the diagonal elements, and the inter-construct correlation. These are the square root of AV values. And these are the inter-construct correlations. This should be more than these values. This should be more than these values. This should be more than these values. Or you can write it in a paragraph format also, and you can report it. Both ways it is possible to report. But both this has to be reported. There is something more that is often reported. Sometimes it is, some people ask for it, some people don't ask for it. That is this thing, indicator reliability. Now, what is indicator reliability? It is a value of 0 to 1. Anything above 0.5 is good. It is similar to, as mentioned in the slide, you can see it is similar to the communality in EFA. You know, when you are doing exploratory factor analysis using SPSS and all those, you check something called as communality. Communality values for all the variables should be above 0.5. So in this case also, the indicator reliability can be checked. And that is nothing else but the value I showed in the SMC table. That is your squared multiple correlation table. These values are your indicator reliability. You can see some problems here, slightly problematic in some of the cases. You need to recheck and all those. Overall, it should be around 0.5 or more. But this indicator reliability, sometimes it is reported. Generally, we do not report it, but sometimes some papers or some reviewers may ask for it. And then you need to report it. Any doubts? Otherwise, we'll go to the structural model part.
Professor, can you just repeat indicator reliability part?
That is nothing else but communality. In EFA, you use communality table is there now that you get.
Yes.
It is exactly that individual communality value. So that is your get from that output. There is a table called squared multiple correlation, which you use for that AV value calculation.
Yes.
Those values are directly that communality values or indicator reliability.
Okay, okay, Professor. Thank you.
What percentage of that variance of that particular item is explained by that factor?
Okay, Professor, got it.
That's what it is to be reported, but that is not a very necessary thing. Generally, we do not report it, but if some reviewer or some journal or somebody asks for it, then you need to show it. Okay. Okay, so now we will go to the next part. That is your structural model. A measurement model we have talked about. We need to look at structural model. Now, same diagram I have changed a bit. I'll show you. Just here. You can see the same diagram, but I have changed it slightly. What is the change? Can anybody tell me?
Linking of dependent and independent variables.
Yes, the dependent, independent. The regression part is now coming in. So in this case, you can see there are two variables, CS and CL, which have taken as your endogenous variables. Endogenous is the dependent or Y. We have two types of regression here. One is CS is the endogenous or Y variable, and ER, IS, SC, and S are the X variables. The second one is CL as the Y variable or endogenous, and then in that case, all the other 5 are leading to it. So simultaneously, 2 regressions are coming into picture. You can see, which if you have to do regression, have to do it separately. But in this case, we are doing it both together. Now, what is the change in the diagram? If you compare it with the previous diagram, go back to the previous diagram. What happened? Yes. So you can see all factors, we had covariances. But if you look at now, in case of structural model, I have removed the covariances between CS and CL, and with CL, with others, we have removed. Only those which are X variable have their covariances there. How? I'll show you. See, the covariances between CS and CL with others has been removed. And instead of that, we have put a one-way arrow between the other 4 construct in CS and from all 5 to CL. And since these 2 are the independent variables, CS and CL, we have added these error terms. 2 error terms have been added to this. This is the change. So those which you are using as the dependent variable or Y variable or endogenous variable, from them, all the other these covariances or 2-headed arrows has to be removed. It should remain only among the X or independent variables. And the 2 variables which are used as endogenous or Y variables, you need to put an error term or add an error term to these 2 and also draw a one-way arrow from all the other variables to the endogenous or Y variable. So in case of CS, you can see 4 arrows from ER, IS, SC, and S to CS. And in case of CL, you can see 5 arrows from ER, IS, S, SC, and CS to CL. This is exactly the change in the diagram. This is exactly similar to what we have shown you when we talked about the notations. I'll go back to the notation, then you will be able to clearly understand what exactly I am talking about. We have shown you 2 diagrams. One is this measure model. You have these covariances. Added to the endogenous variable. That's the difference. And exactly similarly, I have done in the model. I have added or removed the covariances from CS and CL, which used to be as endogenous variables from all the other 4, and then added a one-way arrow from all the other variables to CS and all the other variables to CL, and added an error term to both CS and CL. Clear? What is the change in the diagram that has to be made? So that is exactly the change that you have to make. So in this case also, you need to load the file. Just like previously, go to the output, check whether the things are there or not. And after you have done that, you can see the output file is still invisible. Once you run the estimates, then only you get the output file. Otherwise, you will not get the output file. So this is the output file that you have got. Let us go to the estimates directly in order to check for the regression equations or the effect of all the other variables to CS and CL. So first, the p-value you need to check. So from SC to CS, it is significant, highly significant. From ER to CS, it is significant because it is less than 0.05. From IS to CS, it is significant. But from S to CS, it is not significant because it is value having more than 0.05. P-value is more than 0.05. Now from the other 5, that is CL as dependent variable. ER to CL, not significant. IS to CL, not significant. SC to CL, not significant. S to CL, significant. CS to CL, significant. Clear? Which one are significantly affecting? Which X variable is significant and which Y variables? And the beta coefficients are here. Standardized beta coefficients. What is the difference between the standardized and unstandardized beta coefficients? Can anybody tell me?
These coefficients are generated because of values changing based on Z score.
That is fine. That is what I am saying. What is the use of beta coefficients, which is unstandardized and which is standardized? It is the same as regression. Regression mein jo hota hai, same it is being used here.
In standardized, where if at all we have used to measures if they are in a different units, scales, then we can, through standardization, everything becomes in the similar.
Yeah, that is fine. No, I am saying when you are interpreting the results, what is the use?
Not sure, Professor.
This is unstandardized values and these are the standardized values. Unstandardized beta coefficients, standardized beta coefficients, same as regression. The use is when you are trying to see the effect. How is that particular X affecting the Y, X1, X2, X3, X4? Then you use the unstandardized beta coefficient to show how much is the effect. If we increase this by this amount of unit, how much standardized variance unit of the variance, it is increasing or it is decreasing, depending on the coefficient is negative or positive. We will look at the effect, unstandardized. But if you have to compare among the coefficients, so 4 coefficients are there. Which one has the highest effect? Which one has the second highest effect? Which one has the third highest effect? You use standardized regression weight to standardized beta coefficients to check which one has the highest. The ranking is using standardized and the effect is calculated using unstandardized. How much it is affecting, is it positive or negative? Depending on that, it will be the standardized variations will be used. But when you have to rank among the coefficients, which one has the highest effect among all the x's, which one has the second highest effect, then you use standardized and then you use the absolute values of the standardized weights, not looking at the plus or minus sign. Clear? So in this case also it is similarly. Only thing is that when you are talking of comparing or ranking the variables as the effect of the variables using standardized beta weights, then you need to look at only the significant ones. The non-significant ones has neither to be looked at, neither to be reported. Because they are not significant, that means they are not having any effect. Clear?
Yes, Professor.
Yeah. So we know that which ones are significant, which ones are not significant, then how to report it in case of you are sharing in the report in a research paper in this way. the standardized path coefficient or beta coefficients is there. The hypothesized path is talking of, and the p-value is shown. Depending on that, we are saying whether it is accepted, whether it is rejected. Which is non-significant is rejected. That means it is not having any effect. Which is significant is accepted. So among the accepted ones or significant ones, if you have to rank them, you have to use standardized beta values. And that means you have to look, for example, let's the first one, with 3 are significant. So out of that, the highest effect is of CS, followed by customer service, followed by tech Israel. And in this case, highest is customer service, followed by tech convenience, followed by tech is reliability. So standardize helps you to rank. So this is exactly the way it is reported. Any doubts here? Anything? Now, in case of structural model, also you have to report those model fit and etc. Now, in case of CFA or measurement model, which is the first part, you do the model fit and you look at the reliability, you look at the convergent and discriminant validity, and then you report this table, which is this standardized estimates, p-value, AV, CR, and all those that you do. But when you come to the structural model, that is the regression part, which you just now did, in that case, of course, you need to write this hypothesized price and the p-values and whether the path coefficient, or this is called the path model or model, whether this is significant and what is what. That is, of course, you have to do, because based on that, you can say whether the hypothesis is accepted or rejected. However, along with that, in case of structural model, again, you have to report the model fit indices. The model fit indices has to be reported in case of structural model separately. So the values will not be much different, but slight changes will be there because the diagram is slightly changed. Slight changes will be there, but instead, in spite of that, whether if it is not changed also, the values are, you have to report the values of the model fit indices again in case of structural model. So in the case you are using both CFA and structural model, in case you are using a paper, this paper was the first paper that I showed to you, was a paper which is talking of only CFA. I have done CFA and I have stopped. So I have not got into, only one times I have needed the model fit. But in case of structural model, in this paper, I have done a CFA, and after CFA, that is measurement model, we have done a structural model also. So once we have given the model fit for CFA or measurement model here, then we look at the reliability, construct validity, and all those things. And after you have done that, again for the structural model, again I have reported this model fit indices. This has to be reported 2 times actually. Both is important. Clear or not? Any doubts here? Anything? What is the basic difference between a measurement model and a structural model? What exactly is the basic difference? Yeah, structural model is basically the path analysis. Measurement model is factor analysis. So the basic difference in measurement and structural model is, in measurement model or CFA, you are doing or confirming the factor analysis of the factor structure. So in that case, all your dependent, independent variables, all the construct is just considered as only a single construct, and you have to put in all the constructs. It's not like that. Sometimes people make a mistake that only the X variables or independent variables you do a CFA, and you don't do it for the independent variables or the Y variables. When you are doing a CFA or measurement model, you need to run both, all the constructs, whether it is a dependent variable, whether it's an independent variable, all your exogenous, endogenous, all the constructs should be there, because it is testing the complete factor structure of your model. So once you have done that, a confirmatory factor analysis, and you have checked for all the things, that means first you need to look at whether all the paths are significant. In case of all the items are loading significantly in all the factors. If not, you may need to remove or rerun. And then you need to check for the model fit. That means if model fit is not achieved, you can use the modification index, which I call as legally illegal or illegal illegal way. You need to use that and then use it for your and use that modification indices continuously for improving the model fit. And then once you have done that, then you need to look at the reliability and validity parts. The reliability is done checked by using the AV and CR values. The AV value should be more than 0.5 and CR value is more than 0.7. And then after you have done that, you need to check for the constant validity, which is done by convergent validity and discriminant validity. Convergent validity is all your factor loading values should be more than 0.5 and AV value should also be lower than 0.5 for all the constructs. Discriminant validity is checked by comparing the AV values with the squared inter-construct correlations. AV values should be more than squared inter-construct correlations, or it should, or square root of AV value should be more than the inter-construct correlations. So all these things has to be reported in your report when you are writing a paper. And once you have done the measurement model, then you move towards the structural model, where you remove the covariances from the endogenous or the Y variable or dependent variables, right? A one-way arrow from all the exogenous to endogenous variables, and put a error term to all the endogenous variables. That is the change in the diagram. And then you run the analysis. In the similar manner, just like a structural model, there is something called as your measurement model. In the structural model also, you need to report the model fit indices. And once you report the model fit indices, then also you report the hypothesized relationships and check for the hypothesis or the paths which are significant or not. Which of the X variables are significantly affecting the Y variables? How? The advantage of ACM is, instead of having number of regressions with only one model and one run, you can check for multiple regression type relationships together. That is the biggest advantage that we have in this case. You need to report both the hypothesized relationship as well as model fit indices in this thing. Clear? Or any doubt? If you have any doubt, you can ask now. One more thing which was not shown before is, I'll show you one more thing. This is a measure which is used, but not that much. Sometimes it may be needed. You have this table called as observations farthest from 100 degrees distance. This. Now this is very rarely required in some cases when you are not able to improve the model fit by the modification indices to an acceptable level. It may happen because some of your data points are out of range or outliers, what you call as outliers. That is what it is being done. So when you are talking of outliers, this table helps you to identify certain outliers. See, when you are talking of ACM, you need a large data set. First thing is that sample size should be quite high. You cannot run ACM with only 50, 100 and data points and all those. You need a large number, 250, 300, 400. Larger the number, better will be the model. The better model fit will also come. Now, in spite of that, you may have some outliers, which you can identify them. This is showing in your data which one has the highest deviation, or data point number 85 having the highest value is one which is an outlier, possible case of outlier, not always. So if your model fit is not increasing after a certain point using the modification indices, you can come to this particular table, observation for this moment distance, and see the high values. So 2, 3, 3, 4 high values or highest values, those data points you need to remove from the data set and rerun the model again. In some cases, it can help you to improve the model fit. Not always, but in some cases, it may happen. In some cases, it may happen. Any doubt or clear? Just 1 second, huh? A call is coming. Just 1 second. Yeah, actually the call was coming from IMI here only. There is a feedback form which is generally sent during the session, but due to some technical issues, it is not been, they're not able to send it. Mr. Umakant, who has sent you all the details, is not able to send it. So he was calling to just inform you that there is a feedback form which will be sent later. So whenever he is sending that, please feedback form. That's what, basically. Okay. Yeah. So the last point, the distance, okay, that is also used for model emission distance, that is for model fit incubate. So just let me know if any doubt is there. Otherwise, we are more or less at the end of the session.
Professor, last one, you mentioned that we have to remove the, which is having highest distance. So can you just show that screen again? And
yes, this is one. The highest distance is one, this 90.83.
How can we know that that belongs to particular?
This is the observation number 85. So if you look at your data set, it is serially 1 to 290 data points are there.
Okay.
This is the number 85. The next one is number 124 in your data set, serially.
Okay, Professor, got it.
Top to bottom, it is like that. The same number, serial number you have to look at. So highest, the highest outlier is number 85, serial number 85. Next is 124. Next is 220. Next is 283 in this way. So you generally don't remove a lot of them. Try out by removing 2 or 3 of them and then check for the model fit again.
Okay, Professor. Thank you.
It's again an iterative procedure, just like the modification indices. Okay.
Yes, Professor.
Yeah.
Professor, can I ask one more doubt? It is
Yes.
is that common method bias, will it come under part of this, or is it a separate concept we have to?
Yes, common method bias can be done by through EFA also, through CFA also. So generally we report that common method bias. So what we do is, in case of EFA, just like you have put everything under one, na? You try to put one factor and try to check it. Na? In the similar manner, when you are talking of common method bias through CFA, you can check it by putting all the items under one your construct. But that is nowadays not much used, actually. Common method bias is something which is, people say, is not that much relevant nowadays. But still some channels or some US may ask for it. In that case, you need to just check for all the variables. Instead of 6 construct, now put all the variables under one construct and check it.
Okay, Professor. So it is not mandatory to report the common method
No.
bias.
It is not mandatory. But sometimes if they ask for it, you can report it.
Okay. Thank you, Professor.
The 2 papers that I have shown you today, none of them has reported common method bias. And both of them are in VDCA journals.
Okay. That was my doubt. Yes, thank you, Professor.
So you may, if somebody asks for it, it is not mandatory. Somebody asks for it, you may need to report it.
Okay, sure.
Yeah. So that's what it is. So next week I will be going for an advanced version of ACM next Friday. That is talking of moderation, mediation, etc. of the ACM. So that is next Friday. We have another workshop on ACM, which is advanced ACM version, which is moderation and mediation we'll be talking of. And they will send you the feedback form. Whenever they send you the feedback form, please have the feedback form. That's what the message was just from Mr. Makat. So if any other doubt is there, you can ask. The floor is open. More or less I've discussed what are the relevant points. You can ask the points. So let me know. If anything is you need to ask. Yes, any doubt?
Yes, so far it is clear, Professor. Thank you.
Yeah. So you remember my email ID. If any doubt comes later also, if you practice, it is more or practice that you will make you confident. You need to practice continuously these things. Whether you are using SPSS, whether you are using SAS, MMOS, you need to continuously practice. So if you have any doubts later also when you practicing and all doing these things, you can call me later also or contact me later also. Okay. As of now, we will be closing the session if there are no more doubts. Okay. Sure.
Sir, when will you be sending the link, sir? Nagendra here.
That Mr. Umakant will directly send you. I don't know whether he will send it today or tomorrow, but he will be sending you directly.
Okay.
Mr. Umakant, who has sent you the link for Zoom and all those, who is the coordinating the thing, he will send you the link.
Thank you so much.
Generally, he sends it today evening or tomorrow morning, I think.
Thank you.
Yeah. Yes. So some of you who will be doing that next advanced one, we'll meet again next week. Yeah. So let us close for the time. Shall bye.
Thank you, sir. Thank you. Bye.
Yeah, thank you, Professor. Have a great day.
Yeah.